Well, good morning, good afternoon, good evening, depending on where you are in the world. My name is Stephen Griggs, and I'm the Vice President of Sales Engineering here at Ragent. I'd like to welcome you to Ragent Health's webinar in a series of webinars on Ragent's new edge computing product line we're calling Cowbell. Some housekeeping items before we get started. This webinar is being recorded and will be archived and posted to our various pages, allowing you and others to view it later. We currently have everyone muted except our presenters, but rest assured that your questions are extremely important to us during the course of this webinar. We would really appreciate seeing your smiling faces and encourage you to turn on video because we're trying to create kind of a completely interactive webinar session today. We will have some question breaks during the webinar, so please take note of the Q&A button down towards the bottom and also the raise hand button in the taskbar. Feel free to open the Q&A pop-up and type your question in real time so that we can address them, and we will do our best to address them during our Q&A sessions. Those that we don't get to because of time, they will be addressed and shared later. We will try to make sure that we respect everybody's time and try to keep this down to about an hour. So today, our main presenter is Muthu Chandrasekaran. He's a PhD and is Ragent Health's VP of Artificial Intelligence. Also present will be Mohammed Anjum, who is our Vice President of Hardware Systems at Ragent Health. He is the Cowbell hardware lead engineer, and one of his specialties is embedded system design. Also in attendance will be Vladimir Kondrenko, a project manager at Ragent Health and leads the Edge platform team. So without further ado, Muthu, I'd like to hand it off to you so you can get started.
All right, thank you, Steve. Thank you all for your attendance. My name is Muthu, as Steve said. I am the product lead for the Cowbell. Without further ado, I'm just gonna get right into it and talk about what is Cowbell. So we define Cowbell as a distributed computing hub and a platform as a service to simplify the delivery and management of AI solutions at the edge. So let me elaborate just a little. So I'll get into the details later during the presentation. So why it's a distributed computing system? What does that mean? It means that each node can be a part of a larger computing cluster of nodes to enable pooling of compute resources to handle large applications. So we leverage Ragent's InstaMesh networking protocol to enable the cluster formation and management over mesh. It's a hub because it can integrate and ingest and process multimodal data streams, cameras, textual data, video feeds and sensor data from disparate data sources via wired and wireless communication modalities. Its main value proposition is to simplify and the delivery and management of AI and other data-intensive applications at the edge with what we are calling ML ops in a box. And more details on that later during this presentation. So what are the main added values of this platform? So Cowbell provides an integrated user interface for managing the cluster of cowbells discoverable in the network and all of the applications that are deployed on it. So we put in a lot of effort to ensure that all of the platform services use cloud native technology. So for the most part, most services are easily deployable on several hardware platforms, including on the cloud. So we've automated a lot of the application deployment tasks, reducing the heavy reliance on IT and highly skilled DevOps engineers and subject matter experts at the time of deployment, and subsequently during the maintenance and monitoring of these applications post-production. So to our knowledge, we are the only single vendor solution providing the trifecta of hardware, software, and networking infrastructure for an edge computing solution. And this decreases a lot of the associated infrastructure and IT costs and improves ROI. So where does Cowbell fit into the picture of a data ecosystem? So Cowbell sits at the edge, and it can be used to ingest data from sensors and other instruments in the field, and can also act as a gateway for the data into the organization's private cloud. So, but more importantly, because it has the compute capability, they can be used to process the input data pretty close to where it's being collected. So we can provide low latency, actionable insights, and affect timely intervention. And so by generating these insights, we're generating also some new data. So just to be clear, Cowbell's not intended to be the system of record for all of the data. You can think of the Cowbell as being a temporary accommodation for raw input data. It'll store this data for as long as needs to generate the insights and affect the timely intervention, as I talked about. And then the main objective would then become to hand off the data to a system of record for the data, which is typically in the organization's private cloud. Either it's in over the internet or it's on-prem on their premises. So the old data in the Cowbell is just recycled and written on top, written over. So the cool thing is that it can make real-time decisions on what data to send and when to send the data. So that's why it's a pretty interesting edge ecosystem. So why edge? Most of us know why edge computing is important. Security, cloud costs being some of the biggest reasons, but there's a reason that that is really interesting and somewhat counterintuitive. And I'll explain. So as we know, a lot of the devices these days are generating huge amounts of data. So network bandwidth limitations make it almost impossible to send all of this data into the cloud. So to counter this, data acquisition systems typically either send smoothed or average data only, or heavily sample the data before sending it. So now if insights were generated in the cloud and they're basing these insights on reduced information, it makes the insights that you generate in the cloud less accurate. So edge computing actually improves the accuracy of your insights despite it being a heavily resource-constrained environment. So I thought that was an interesting information tidbit. So edge deployments has, their own challenges, but because there's a lot of infrastructure that's needed to support edge deployments, and it requires a multi-vendor solution. So typically the hardware guys say that it's the software guy's fault, and the software guy says the network's fault, and no one really wants to claim liability for any failure that happens. So on top of that, software vendors build software that's hardware agnostic. So while that might be somewhat beneficial, they're not typically optimized to maximize the use of the hardware and so on. So scalability is another big issue. So since edge computing hardware is heavily resource constrained, so extensibility requires expensive virtualization and data management licenses, and involves a lot of upfront investment and planning. And to add to this, productionization of AI is also quite hard. And a lot of additional infrastructure is needed to just support AI systems. So that tiny black box that you see called the ML model is a core piece of intelligence that adds business value. Machine learning scientists create that model. And machine learning engineers are then involved to typically to take that model, help package it, create a service that exposes an API and exercise the inference capability of that model. We then have data engineers who are then responsible for building the infrastructure needed to pipe data into the system in a format that the model understands, and pipe the insights out of the system to the corresponding downstream applications so we can provide business value. We then have analysts to help interpret the data and derive business value from these insights. So it doesn't just stop there. Maintaining and monitoring the systems closely post-production is also very key. So this will allow provisioning an active learning workflow, if you will, so systems can automatically adapt and get better over time. So as you can see, productionization of AI requires highly skilled and expensive people working together all the time to deploy and maintain a complete AI-based solution. So where do you get the skill? The skill is also really very hard to find. This labor is also really hard to find. So what we've tried to do with the Cowbell is to systematically address a lot of these challenges and automate a lot of the processes and provide tools to simplify not just the delivery, but also the maintenance of these AI systems and applications. As an example, we provide a simple user interface that provides like a red, green, yellow status and of the health of the cluster and the availability and status of the application. So even a field operator who is not trained in machine learning can easily determine if an AI system is healthy and operational. So we don't need expensive AI scientists constantly looking at dashboards in the field post-production. We're also looking into implementing AI-based first-year support systems to help troubleshoot common problems before a human needs to get involved. So allow me to summarize some of the different features of the Cowbell before we stop for a round of questions. Excuse me. So how do we enable ML ops in a box, and how do we bring applications into the platform? So we've created what is a microservices based software architecture. It's a very popular software architecture paradigm. It allows for easy extensibility and seamless integrations with external and customer applications. So one of the things that we want to provide here is a seamless integration with customers' own applications into this platform. So with very little effort, depending on the maturity of the customer's applications, software applications, we could easily integrate them into our platform. And the integration process could take less than 2 days to create the necessary configuration and the launch files needed by our application orchestration system to maintain its availability even after a power outage or a node dropout. So we also provide out-of-the-box support for streaming and batch data pipelines with native support for middleware like MQTT or ROS, which is also known as robotic operating system. And some of these pipelines can even be dynamically configured at runtime. So we also provide application level metrics to show the health and utilization of resources available in the cluster. And as I mentioned earlier, it's a distributed computing system because at some point the resources are going to get used up. So extensibility becomes super important. And how do we address that? So for us to create a cluster of nodes, all we have to do in the deployment is to turn on another one of these nodes and add them to the cluster using our user interface. And when we do that, our software platform, the Cowbell software platform, can automatically distribute the application workload to any of the applicable nodes in the cluster. So why do I say applicable nodes? It means that you could actually target applications to go to a certain type of node. So you could have, say, for example, we could have a Cowbell that is deployed on drones. We could have Cowbells that are deployed on static infrastructure or mobile infrastructure. So you could decide certain applications need to go to certain kinds of deployments, and we can enable that seamlessly through our software platform interface. And the software platform also ensures that whatever applications we've deployed is always available. And even if a node goes down, it automatically reallocates the applications that are deployed on that node to another available node in that cluster. So we've also created what is called a networked file system to allow redundancy of mission critical data to enable application survivability at the time of failures to allow failure tolerance. So we also provide role-based access control and user management through the same interface. So the integrated management tool that we're calling the device manager can be thought of as the BC commander for the Cowbell, in familiar terms. So we've also taken a lot of care to allow easy remote management of the device and allow over-the-air updates of both the Cowbell and the applications hosted in the Cowbell. So Cowbell is also pretty easy to deploy. Like I said, we just have to turn them on. They automatically discover other Cowbells in the network, and you can intentionally add them using the user interface into the cluster. So they can be deployed indoors or outdoors. They have the hardware enclosure is suitably rugged. It has an IP-rated connectors, and the enclosure is IP-rated. So and we have passive cooling. The hardware components in the Cowbell are rated for applications ranging from a refrigerator warehouse, like -25°C, to functioning in the middle of a desert during summer to 85°C. Example, oil and gas applications. The computing unit that we have has an integrated CPU and GPU from NVIDIA for handling several multiple tasks simultaneously, and we've created hardware accelerated plugins so a lot of the to handle machine learning workloads, and we have enabling network resiliency. We provide onboard storage of up to 8 terabytes of storage, allowing us to store, process, and forward up to several months worth of data, even if there was no network connectivity to the system of record. And Cowbell it also contains a breadcrumb. It contains a region cardinal. So this is what provides the low latency, high reliability, secure data transport over mesh. And the cluster formation also happens over this communication networking backbone. So the Cowbell's network configuration can be managed like any other breadcrumb using the BC commander. Really, there's no difference in how you manage the Cowbell's network infrastructure and the network configuration. For additional security, we can easily integrate with the Radiant inline security module, like the RISM product line. And we also provide secure remote access to the edge cluster for maintenance using VPN out of the box. So we have a VPN client in the Cowbell deployed with every unit. And last but not the least, we also provide native support of peripheral provisioning and management for some select peripherals using our device manager. So we at Radiant Health, we also develop a wearable hub called the QStat, and we provide native support for managing and provisioning the QStat, which is a medical grade health wearable with a lot of features, and I'm sure we'll have another webinar talking about the QStat later. And so the cool thing is that it can hub into sensors, like I talked about, and systems either wirelessly over Wi-Fi or Bluetooth, or wired over serial or Ethernet. So we're also developing a variant of this that will allow support for interfacing with LoRa-based sensors. So I guess that's the summary of features. I guess we'll stop briefly here for questions before moving on. What do you say, Steve?
Yeah, it looks like we've got a couple. Mario, if you could please unmute and pose your question live. We'd like to hear it. Yo, Mario. Okay, well, in the absence of...
Hey, look, sorry, Steve. Sorry about that. I don't use Zoom too often. I was trying to work out how to unmute myself.
All right, no worries, man. No worries.
No, thanks, gentlemen. So first of all, I asked about the size and storage capability, and we answered that in that last there with 8 terabytes. Thank you. Just wondering then, is that a segregated storage for the operating system and the running of the AI and things like that, and any apps you might have over it, and then the storage of data, or is that all inclusive?
Yeah, we do have a logical partitioning of the storage. In fact, we have 2 expandable storage slots inside. So we could technically use one of them for the OS and storing a golden OS boot. So we can reset it back to the factory settings. But we also have the data extension. So we could go up to 8 terabytes in total.
Right. Okay. Good. Thank you. And I guess the only other question I had at this point, when you talked about the ease of an engineer saying, you know, red lights, green lights, blue, yellow lights, sort of thing, I assume you meant that was through its own user interface. Is there a way of integrating that user interface into a site's SCADA or something like that, so an operator would only need to be looking at one screen?
Absolutely. So all of our so what we've developed is a notification, alerting and notification system under the hood as a microservice. So we can take that. We use standard, you know, event-based middleware like MQTT or other IoT based messaging platforms. So we can push those alerts to any system that the customer is used to using. And we've done this also previously because, for example, we have an application that I'll talk about later that, you know, our robots detecting and scanning barcodes and even though we have an interface where the barcodes, if the barcodes are not matching with the inventory, we throw an alert in our user interface, but we can also take that same alert and then hook up to the operations manager's interface that they use in the facility. So they can dispatch operators to go and fix the problems in the inventory directly. So we have, so the user interface that we're talking about here is just to maintain in a single pane of glass, look at applications, look at the devices that we have in the cluster, look at the resources. So it's just to maintain internally whether the applications are live and running. But the actual application level alerts are also can be integrated into any customer's ecosystem.
Great. Thank you.
Awesome. Awesome. All right. Mr. Kamian Schwartzman, he's got a question. Kamian, if you'd like to unmute, please, sir.
Sure. Hey, Mutu, great job. Can you tell me, does the Cowbell require internet or does it need to be cloud facing?
Sure. That's a good question. So the Cowbell is designed to be deployed in even air-gapped environments. So you absolutely don't need internet connectivity because a lot of the processing that we do on the Cowbell is independent of any external system. So as long as you're in the network and you can provide the data into the Cowbell, all of the processing happens on the Cowbell. But like I said, it's not a system of record, right? So that means all of the data that we generate from the Cowbell and also process using the Cowbell needs to somehow be handed off to a system of record. So that could be over the internet, or it could be on-prem in that deployment, depending on the application and the use case. The other reason why you might want internet connectivity is if you want to provide remote support for, say, a developer to go and fix some problems, push an update, over-the-air updates, things like that, unless these provisioning servers are also hosted locally in the same network. So realistically, the need for internet is not even there. So we've had application deployments that, because we provide our own networking and also the processing, we really don't need any other. We are self-sufficient, and all of the applications can be hosted and can communicate over whatever is available on the Cowbell platform. Does that answer your question?
It does. Thank you very much.
Cool.
All right.
Thank you.
One more Mutu, and then we'll get moving. And this question will actually kind of give you a good segue into the next part of your webinar. So, Sagar, Mr. Chandra, if you could please unmute and ask Mutu your question.
Hey, don't make it too difficult, man.
Yeah, so a lot of my customers may not understand how to use a cowbell. So can you give me some examples, some ideas of what I can tell the customer how to use a cowbell? What have you used this? Some examples, please. Real life example.
Yeah,
Like
that's exactly
solving
what
a
I
real
was gonna-
life, like solving a real problem.
Yeah, let me answer that in two different parts. Okay, so so one I'll talk about next are a bunch of applications that we have developed to show proof of value of what the cowbell can be used for, and open people's minds up a little bit about the versatility of the platform. The second, I want to talk about the simplicity of the actual deployment of the system. So if you're looking about if you're say you're a Ragent customer already, then you have infrastructure that's already got Ragent breadcrumbs deployed, and so now you want to add some compute capability and do some edge computing. So what you would do is to just turn one of these cowbells on, configure the network to mesh with the existing mesh ecosystem, and now we can route data into the cowbell so you can get edge compute capability, and you can use the same networking backhaul, communications backhaul to pass the data over to wherever you want it to go. So deployment into a Ragent mesh ecosystem is as simple as turning one of these nodes on. And if you want more communication capabilities, you just turn one more of these things on. And if you have three or more, you can provide a failure tolerant high availability cluster as well. And so let me.
Well, one second, Muthu. Just we're going to get into some of those applications here in just a couple of minutes, Sagar. But Mr. Ferris has his hand up. If Ferris, you'd like to unmute and just pop your question in real quick before we move on.
Hi, good morning and good evening to everybody, wherever everybody is. So I'm just trying to understand a little bit, but going a little bit into Sagar's application, but a quick one. So for example, we have a distributed network of meshes that is being utilized by, let's say, video cameras. So what I see that the Cowbell has is sort of like an 8 terabyte storage that could be additional to it. And then it also has a CPU that could do a lot of applications. So could it be somewhat like an NVR by itself, for example, instead of all the footage of the cameras being streamed or recorded to a central server?
No, absolutely. Depending on the security application. So we're also doing a lot of video analytics applications with the Cowbell that I will also talk about, safety related applications and security related applications, and also even like I was talking about, even the inventory management applications. But to answer your question directly, yes. So the short answer is yes. The videos that from CCTV cameras and others can be processed, and you could choose to send only salient information over to the cloud, and just ignore the rest of the feeds that you don't really care about. Like, for example, if there's a security video feed, 99% of CCTV camera footage is completely useless unless there's an actual problem. And so the key is to intervene in a timely way, right? So we can use the cowbells to process the video feeds and generate alerts and interventions in a timely way, so that if you do decide that you want to have all of the video feeds streamed over to the network, over to the cloud, or some place where you want to store it for auditing purposes, you could decide when to send that data to that system, because you've now timely intervened already, and you can decide when to send the rest of the data and not affect the network bandwidth that you have available to you. Does that answer your question? Maybe
that answers it perfectly. That answers it perfectly, sir. Thank you very much.
All right, Muthu, let's go ahead and progress. Let's go ahead and move on.
All right, Sagar. Yeah, this is probably going to help you understand where we have actually used the Cowbell and what kind of applications we've developed. So just to give you a disclaimer, So we started developing applications to just show proof of value, right? And then when we started developing these applications and we talked to the different customers, and a lot of our customers started, saying, I want the same thing, so can you just really create an application that's much more mature, so we can just use it as is and create a platform, so we can handle these kinds of different disparate assets. And so we've decided carefully, because we're not a large team, we decided to handpick a few applications that are in our strategic roadmap to kind of take and make a mature application out of. And so I'm going to talk about a few of those use cases that we are currently working on. So one of which is a personnel safety, wellness, and environmental monitoring application. Typically, this use case is common in oil and gas, construction, ports, mining, public safety applications, and the kinds of features and functions that this kind of application warrants is, they want to track their people, not just the location of their people, but also health vitals, because they care about the personnel's wellness. So think occupational wellness applications. And so we have, I mentioned before that we've also developed, as part of Ragent Health, we've also developed a health wearable called the QStat. So we've integrated that into this application. So we can, that has location information, it has haptic feedback, it has alerting mechanisms that we could alert the employee or the worker if there's a danger, or it also has audio and things like that. So we've integrated the health wearable into this platform. So now you can monitor the vitals of the personnel. We can also, because it has GPS and also has Wi-Fi and Bluetooth, it can also beacon and become an RTLS tracker, asset tracker, passive tracker. And so we can do proximity detection to heavy machinery, other equipment. We can, so we've created algorithms that can, provide proximity. And so we have, we can track assets and relative to other assets in the system. So we've just generated a simple application that computes proximity, and we can also calculate duration of proximity as well. So you could do contact tracing. So for example, we also have integrated some sensors into this for environmental monitoring, like hydrogen sulfide and carbon monoxide sensors for some of the applications that we are interested in. And so we have anomaly detection algorithms also developed that would throw anomalous readings. So if it detects anomalous readings from these sensors, then there's a low exposure zone that is created, or a high exposure zone that is created depending on the sensor model. So now, using the same proximity detection, we can track how the duration of exposure, if somebody comes in contact with this sensor, comes in proximity to the sensor at the time of the anomalous exposure. And so we've also created applications for incident management. So because some of the wearables and some people, some applications require wearables, some we could just send messages to phones. So we have integrated with things like Slack and other messaging platforms to send messages in case a supervisor decides that finds that, oh, one of these employees has not been moving for a while, so we want to send somebody over to help. So you could just select in the interface who is nearby and send them over and to help the person that needs it. So basically, safety could mean a lot of things to a lot of people. Safety could mean tracking. Safety could mean are you wearing personal protective equipment? So we've also, using CCTV camera footage from CCTV cameras, we've also created AI models for detecting personal protective equipment, like hard hats, vests, and so we can process multiple video feeds using one Cowbell. So imagine there are about 19 applications or so that does this whole all of these functions, and we've deployed all of this on one Cowbell. So that's the compute capability that we can provide with one unit. So if you want to scale this to several other units, it's easy enough to just add one more of these things and provide now twice the capability that we currently have. I see somebody raising their hand. So Ferris?
No, that was for my question before. Thank you.
Oh, okay. I still see. I don't know. It didn't go away. As I mentioned, we are actually actively working on some asset tracking application with a few customers. We're working on a mining application for what is called a blast blocker application. So in this application, it's pretty interesting. So you have these people called blast blockers that go out and have to clear out an area that's going to be blasted in a mine. So they have a blast master that's going to push the button. So there was recently in one of the mines that our customer was dealing with, they had an event where the blast blocker thought that they're cleared from that area of the blast, but they were really not. And so and when the blast master just hit the go button, the debris hit the vehicle, and thankfully they were not in the car, so and they didn't die, but it was a serious safety concern. And so one of the solutions that we are providing enabling using the Cowbell is to use the Cowbell to provide the same incident management capability. So you can send a message to a wearable that the blast blocker is wearing, and use the mesh networking to enable the communications between the wearables and the compute that happens within the Cowbell. Yeah, Steve.
Helps to unmute. Sorry. Before you got too far, this question is from an anonymous participant. But can you please expand on the LoRa network server application?
Sure. Yeah. So this is one of those things that we've been working on. It's a variant of the Cowbell that has a LoRa gateway concentrator module that integrated into the Cowbell. And we have hosted the network server application as one of the applications that we manage within the Cowbell's within the Cowbell itself. So if you want to talk to an asset tracker, let me actually show you. I have a video so you see these blue color things here. Those are actual LoRa based asset trackers that publish their GPS locations over LoRa. So this is an example. I think if I play this, you can see this is some of these sensors are simulated, but just to show you, we have integrated CCTV cameras. This is incident management. It shows the duration of exposure to sensors and equipment. This is an early user interface, so we've not really cleaned it up yet. But so you can see, you could send a message from this dashboard to a particular QStat. And when they send this, not only does it vibrate the actual QStat, which is our wearable, but also it sends a message to Slack notifying the incident that was just created. And it happens for of course, if you want Slack connectivity, you need internet connection. But if you want to send a message to the wearable, it doesn't need anything. And so you see on the right-hand side, there are applications, there are alerts that I'm exposing. So this shows the PPE detection on CCTV camera feeds, and the alerting mechanism on the right-hand side. So all of this is integrated into one user interface, and these are all the applications that are running behind the scenes on the Cowbell. So just to give you an idea. And we can manage, all of these applications from this interface. So we also have another application that that involves, similar technologies, but we've also created what is called a media server. So you could take any RTSP feed from CCTV cameras and then render them on a web-based interface, like a web browser. So so you could take a body cam or a CCTV camera and then render them in a user interface like you're seeing here. So and then we also use the health wearables to track the actual heart rate. So this person seems to be doing something that's raising their heart rate up to 177. So that's not great.
In a follow-up there, Mutu, from this from an anonymous participant, what may I know what type of wearables can be deployed?
Oh, absolutely. So I'll talk a little bit about some of the wearables we've integrated with. One is obviously our own wearable, but we've also integrated with Holter monitors like the chest straps that publish data over Bluetooth. We've integrated with FDA capable ECG monitors that you could put your fingers around and it publishes data over Wi-Fi. We've also integrated with patient monitors, those that you see in ICUs. So this is we've actually done that for another application for large animal monitoring that I'll talk about shortly. So for that application during surgery of that large animal, we integrated through the serial port on the Cowbell the patient monitor data, and we compared that against the wearable data coming out of our QStat wearable, and compared and contrasted the data. So and create an analytics report in real time. So there's a lot of cool things we can do. So specific, we've also integrated with like temperature and humidity monitors and some LoRa-based asset trackers. I don't know. Currently, we don't have. We've also integrated with the Empatica wearable, which is another medical wearable device that publishes data over Bluetooth. Is there any specific wearable that the person is interested in? Because for us, as long as it really doesn't limit us from, as long as it communicates over Bluetooth or Wi-Fi or LoRa, we can, and they provide a data API, we can integrate with those wearables.
Okay.
We just have to create the integration would be as simple as creating a microservice that handles the data API of that wearable. It's like an adapter, and then we can use that microservice to internally provide the data feeds that we want for consumption with the rest of the applications that we have inside.
Okay. All right. Good deal. All right. Charles, please. Hello, Charles.
Yeah, I have a quick question. Just, is there anything you're doing on the Bluetooth side to improve distances? Like, what are you seeing for distances from these devices? It was typically those distances are pretty short, correct?
Yeah. So typically, that's why, one of the things that we've done, Bluetooth-based wearables are notorious for really bad connectivity and problems. So that's one of the reasons why we even ended up building our own wearable. So we decided to provide a network resilient, wearable device that can provide large quantities of data, including raw health PPG waveform data that I don't think any other wearable provides in the market that's commercialized right now. So we saw a lot of problems in communications, and which is why we started building our own wearables. And the Bluetooth obviously is very bad and there's also an upper limit on how many devices you can connect over Bluetooth. like I think there's like a limit of 7 devices or something like that if you want to intentionally connect and pull data through. And even with 7 devices, you cannot stream data at 200, 300 hertz. So what we've done is we've created essentially with our wearable, we've created a couple of data pipelines. So one of which is a monitoring data pipeline that will allow you to just, for situational awareness, display your vitals on a screen, right? But then we also have what is called an ingestion pipeline. So imagine collecting all of the raw data required for downstream machine learning and other applications that requires all of this data to be ingested. Say a clinical trial, you want to have all of this data ingested for a clinical trial and post processing later on. So we built data pipelines that ensure data integrity and the order in which the data is being published. And we have handshakes to ensure that all of the data is received. So we've taken a lot of care in ensuring, at least with our wearable, because we control it, create these really network resilient data pipelines. Even if we lose connectivity, we also have persistence in our wearable that will allow us to store data locally. And our Cowbell can have and do the handshake and get data out of it. And so we are severely limited with the publicly available wearables because of the data APIs that they provide. So that's why one of the main reasons of we decided to build our own.
Yeah.
Okay. All right. In the interest of time, Muthu, we should probably move along. We got about 12 minutes.
Sure. I just want to talk about 2 more applications. One of which is very interesting. This is for a warehouse application, inventory management application. So this is a refrigerator warehouse. The system that you're seeing here involves a few static cowbells, the white boxes that you see. That is not only a compute module, but also a mesh networking node. Interlaced with other breadcrumbs to provide communication in the entire warehouse. And so we have a drone that's tethered to an autonomous mobile robot. So the mobile robot is essentially a platform for carrying batteries, and then the tether is to power the drone, and the drone is essentially a platform to carry cameras. And the cameras are looking at barcodes as the drone's flying up and down these different aisles and bays. It's looking at barcodes and detecting the barcodes, decoding the barcodes, enhancing the images if it's needed, and also localizing the barcodes in the warehouse and comparing them against the inventory. And providing alerts to the operations managers so that they can dispatch people if there are problems in the inventory matching. So, and all of this happens at the rate at which the images are being captured. So at 20 or 30 frames per second. So that's about 15 milliseconds per, and all of the live alerts are happening at 15 milliseconds. So the entire end-to-end process up to matching of the inventory happens in 15 milliseconds. So which is pretty awesome. And so what we've done is this is one of those applications where you have different kinds of cowbells. So there's a drone module that we are calling the flying cow, and then we have the cowbell that's static. So it has the same software platform, the Cowbell software platform. So they cluster with each other like as if any other cowbell would. And so you can allocate applications, specifically things like barcode scanning applications on the drone, and you can do mission planning applications, deploy mission planning applications on, or fleet management applications on the static ones. So really, it shows the versatility of how you can manage deployments, in a really complicated deployments. So we showed a version of this at CES this year. I want to share a video. So what you're seeing here in this screen is an example warehouse, and then you have. Let me actually show you the actual warehouse. So this is this is how it looks like. So you have a shelf. They didn't let us fly drones in the in CES, so that we put it on an actual robot, like an industrial arm. We put the camera and the flying cow on the robot, and you see boxes here, and so there's one of these guys that's just, you know, turning the box around so that, you know, we intentionally don't see the barcode, so it's going to show a red indicator on top, so indicating that, oh, the inventory didn't match, and all of this, you don't really need to stop the drone, or in this case the industrial robot, at all. So it just goes up and down really. All of the processing happens in less than 15 milliseconds. And you see the UI on the left-hand side. So I'm going to show the video of what you see on the UI here. So as you can see, the boxes, as they are being detected and matched, you see green. And one of these boxes in the second, you also see the live feed. We use the same media server to show the live feed of what's happening. And then when the box is turned around, you see a red X over there. I know it's not clear, but so it was a nice showcase of the technology. We're actually deploying this on a drone in an actual warehouse, hopefully soon. The last application I wanted to talk about was the large animal monitoring application. So this is for a university, academic university that studies pigs and the effects of chemical exposures on pigs. This is for a combat military application, where they wanted to see how the injection of antidotes, cyanide antidotes, work. So they're testing this on pigs first before they can do anything with humans and soldiers. So what we did for them is to create a data acquisition system and an automatic report generation system and logging system. And all of this happens in real time. So we have doctors that are operating on pigs. They don't really want to click buttons or interface with anything. So we have an automated logging and reporting system that allows us to generate these reports in real time. And we compared and we published the work that we did with them at a military conference last year. So it was a good use case as well. So essentially, to summarize, I just want to say that we've developed a few applications here that showcases the versatility of this platform and the varied use cases that we can support with one of these platforms. The key thing here is not everybody knows ahead of time what they want. And we've seen that with all of the customers that we've interacted with. And so the cool thing is you could deploy the hardware and manage the software applications incrementally. So that's what we did even internally here. The 19 applications that you saw in the first safety one was not something that we planned ahead of time. So we started with just the proximity application, and then we added incident management, then we added that and this and so on. So it was incremental, and the application deployment, and now we're so reliant, so used to using the Cowbell interface. I don't think I can ever go back to a command line and click run bash scripts and be able to deploy these things manually ever again. So it became a way of life for us to just use the Cowbell interface for deploying applications and maintaining them. Yes, I'm done. So I think there's somebody raised their hand. Darren?
Yes, Darren from Crossover.
Hello.
Hello. Can you hear me?
Yes.
Yes, sir.
Okay. Yeah. So if a customer wants to bring their own applications, why should they pay for the platform?
That is a fantastic question. It's so one of the main things, that's exactly what I was talking about just a few seconds ago, is, you know, the simplicity of managing applications is not something that we could discount. It's a real pain. I have some explicitives, but it's an incredible problem. Integration of all of these applications and managing all of these applications together in a unified interface is the value of that, and the time the time saved because of all of this is incredible. And the other main value proposition is the fact that, you know, a lot of the things that a lot of the manual deployment tasks specific to applications that are artificial intelligence based, we have automated. So like I mentioned before, the skilled labor that's required for you to manage these AI applications is also reduced. The reliance on the skilled labor is also reduced. So that's another value that we provide. And then on top of all of this, I think the bottom line is that extensibility, which is so key in edge deployments, we make it so easy. We just turn another one of these nodes on, it automatically discovers, and they're automatically networked. They automatically provide data redundancy and high availability and fault tolerance. So, and we are the only, like I mentioned before, we are the only software, hardware, and networking single vendor solution for hardware, software, and networking. And I think a combination of all of this makes this, even if you brought your own applications, makes the platform in itself highly useful and valuable. Hope that answers your question.
Yeah, thank you very much.
Okay, I think if anybody, I think we've got time for one more. Mr. Mario Pace.
Thanks, Steve. I worked out how to turn this off now. I just was wondering, this is a quick one. Mutu, when you were doing your AI on the hard hats wearing in the thing, did you have any issues with good-looking blokes like myself and their bald heads triggering it as wearing a helmet?
Well,
I asked this because this is something we have tested before, and I am often detected as wearing a hard hat.
Interesting. The only playground is here. I have one here, and unfortunately it's still so I think we should do a lot more testing, but I do not have that problem right now here in the test that we have done. But one thing I can tell you was we had a variety of customers, men, women, at CES. We ran this application for almost 3 days nonstop. And one of the things that we noticed was it was really good. So the way we've developed the algorithms where first we have a primary detector that detects the person, right? And then we have a hard hat detector and a vest detector. And then we find out that if that person, and we associate the hard hat and the vest to the person based on proximity of the detections, and we tie them all together, and we track the person after they are detected. So the entire entity is managed as one entity with properties like somebody's wearing a hard hat or not. So as they are moving around, we're using we are optimizing the way we are processing the feed in a way that we can handle multiple camera feeds and multiple things all using one Cowbell. So we did spend a lot of time in optimization of the video analytics pipelines to provide hardware accelerated video analytics pipelines, and some time on improving the accuracy of the models. But the more customers and more data we get, we can enable an active learning pipeline. So that allows us to update the models seamlessly as we get more data with time. So that's another thing that we provide with the Cowbell is an active learning pipeline.
That's great. Thanks very much.
Sure.
All right, ladies and gentlemen, we are at the top of the hour. So speaking for the rest of the presenters, I'd like to thank everyone for your attendance and your attention. We hope you found the presentation useful and informative, and this is some exciting technology that Ragent Health is bringing to the market. Those of you who know Ragent technology with our kinetic mesh implementations globally, you know that Ragent Tech is cutting edge. We're excited to be delving into the world of edge computing and artificial intelligence and what those possibilities may bring to our partners and helping them develop new technology and applications to bring to your customers. With artificial intelligence paired with edge computing and Ragent Kinetic Mesh, the possibilities are absolutely endless. So with that, ladies and gentlemen, I'd like to bid you a good morning, good afternoon, or good evening, depending on where you are in the world. Thank you for your attendance, and we'll talk to you soon. Y'all have a good day.
Thank you. Bye.